Good morning. We're running out of time before the holiday break, so we're going to read and analyze regression outputs. Okay, so hopefully by the end of this lesson, you can say, I can write regression equations from a computer-generated output. All right, now, you kind of needed to be able to write the equations beforehand. Okay, so remember y hat, the predicted y value, equals b0, the y-intercept, plus b sub 1, the slope, times x. Okay, all right, let's do it. All right, here we're looking at the relationship between the cost of a diamond ring and the size of the carat. All right, now, in the equation, okay, the y-intercept is the constant, okay? So negative 558.52 is your y-intercept. So that's b0. Can you guess what the slope is? Okay, so here we have our explanatory variable. Lovely writing and spelling. Okay, so the cost is going to be, the other one is going to be your response variable. All right, so when we go to write our equation, there's two ways to write it, remember. Y hat equals the y-intercept, negative 558, that was a weird looking 5.52, plus 8,250.1 times x. Okay, again, that's fine. That's not good enough, though. We're better than that. Okay, so cost hat. Again, the predicted cost is equal to that same stuff. Times, instead of x, the carat size. Okay, now, a couple other things of note. Notice you are not given r, the correlation. However, we know r squared. Okay, r squared is equal to 0.987. Notice I took the percent and converted it back to a decimal. And yes, as you mathematically know, we square root that, but here's the thing, we've talked about it, right? Technically, we don't know if the r is going to be positive or negative, but we look at the slope. Okay, since our slope is positive, then so will our r value. So the r value, when square rooting the 0.987, we get 0.9935, which is a super strong positive linear association between these two variables. All right, let's take a look at this one from Microsoft Excel. Notice you're given tons and tons and tons of information here, much of which we do not need. Okay, we will most likely never need any of that. We don't need any of that. Okay, yeah, there's just so much stuff that we don't actually need here. I guess technically we're not going to be running ANOVAs and AP Stats. That would be more of a graduate or postgraduate school type thing. All right, so notice we've got the r squared. Okay, what we're going to find out is that my pen is writing whenever it wants, but that's cool. The r value that you're going to see right there is going to end up being our r value. So notice 0.697 means we're going to have a moderate positive linear association. All right, let's backtrack and look at context, because context matters. All right, here we are looking at the association between NWEA scores and AP stat grades. Okay, notice, again, 0.7 basically. All right, it's kind of hard to find a correlation that high in context and in the real world, but NWEA scores and AP stat grades are quite correlated. This is real data, by the way. I actually looked this up. Okay, I did the investigation several years ago. All right, so we are going to, again, notice this time in Excel, it's telling you the intercept. Okay, that's what it sounds like. That's the y-intercept. That is b sub 0, which means NWEA, your explanatory variable, is b sub 1. Okay, so now it won't let me change the color. There we go. All right, so I'm just going to go straight for context here. So grade hat, the predicted grade, is equal to negative 28.43 plus 0.4372 times NWEA. All right, now, something I didn't do earlier. Slope, let's interpret it. Okay, over 1. So for every 1 additional NWEA point, okay, you would expect someone's AP stat grade to go up by about 0.4372 percentage points. Okay, so for every 1 NWEA point, you'd expect someone's AP stat grade to be about a half a point higher for the year. All right. The y-intercept, which we've talked about, oftentimes doesn't make sense. Okay, if someone scored a 0 on the NWA test, you would expect them to get about a negative 28.5 on their for their AP stat grades. Again, that doesn't make sense. All right, now let's interpret the r-squared value in context. All right, so the r-squared, so 0.48, so 48.6. Hang on, let's. Georgia font, obs. All right, now let's see. So 48.66% of the variation in whatever the y, again, so AP stat grades, can be explained by the variation in NWA test scores. Okay. All right, so now that you know how to read a regression output, I will post an assignment in your Google Classroom, and it'll be due, I don't know, Monday or something like that. All right? Hopefully it's helped. If you need to, go back, rewatch. Check out Chapter 9 or 8 or 9, I believe, in our textbook if you're interested. You should have really no problem with this. I'm sorry if that made you feel bad, but it's true. This is a piece of cake. All right, peace out, everyone.